All right, in today's lesson, we're going to look at even or odd functions and just being able to recognize them. Are they even or odd? Now, first of all, we're going to look at graphically. How can you tell? Well, let's look at the definition. An even function means it has symmetry with respect to the y-axis. So I want you to think of a butterfly, okay? It has a butterfly symmetry. All right, so it has symmetry with the y-axis. So if you fold it along the y-axis right here, these would match, right? So this notation, don't let it trip you up. It's just saying a point over here where x is y will have its reflection over here where negative x and the same y. That's just the symmetry to the y-axis. So this looks lovely. This is symmetrical. This is even. This is symmetrical. This is, so it's an even function. Absolute value is even. As long as that vertex is staying on the y-axis, it will remain even. Now, if it shifts left or right, if that vertex shifts left or right, it's no longer going to be even. Let's look at some examples. So here it is. This one works fine as long as it's on the y-axis, but once I shift it here, if I fold it on the y-axis, they would no longer match halves, would they? It would no longer work. So just make yourself a note. No longer an even function. Okay, no longer even. It's even here, but it moved right, so it's no longer even. So we would just call it neither. It's not an even or odd. Now, what's an odd function? Odd function are functions with symmetry with respect to the origin. Okay, what the heck does that mean? That means like if you have a graph, and in my mind, if I can visually fold it twice, like this way and this way, and they overlap, then it works great. For instance, a linear function, right? If I fold this way and then this way, then it stacks right on top of each other. So that is an odd function. These points are true, okay? That notation is kind of confusing, but like a point over here with a positive xy will have the negative xy version of itself down here in quadrant 3. So examples, well, a linear function is an odd function. A cubic, maybe you remember a cubic function? That is a very common odd function, right? Y to x to the third, y equals x to the first, right? Non-examples. Now, what happens if this origin thing doesn't work, if that linear function doesn't go through the origin, you can't make those folds and ends up being odd anymore, okay? No longer odd if it falls outside the origin. Again, if that cubic function gets shifted somewhere, it's no longer going to be odd. So these are no longer how we classify them as odd functions, okay? Because we moved from the origin. So now, an algebraic test, what we just did was graphics. So what if I don't let you have a calculator? You have to figure it out by looking at the function. Well, a function f is even when for each x of the domain of f, when you plug it in, if you plug in the negative of it, it will come out the positive. It looks a little strange, doesn't it? We're going to plug in a negative x, and it should come out to be the original function. All right? You plug in a negative, it comes out the original. A function is odd if for every x that you put in the domain, if we plug in a negative again, notice we're going to start doing the same thing. This becomes the negative of the f of x function, okay? So go back and change the signs, and then if they match, it's odd. All right, neither one of these happens, we just say it's neither. So let me show you a few examples, and then we'll be done. All right, so g of x. Determine whether the function is even, odd, or neither. So notice to determine this, I start with the same step. I put in a negative x in there. So I'm going to put in g of negative x and see what happens. If I put a negative x in there and I cube it, minus a negative x, let's see what happens when I clean it up. So, well, it'll be x to the third, but a negative times another negative is negative. And this negative times negative is a plus x. All right, now let's stop and think. Does this look like the original function? No, so it's definitely not even. Is it the negative of the original? Well, stop and think. All you have to do that is change your signs of the original. Is it that? Yes, they match, so that means that this one is an odd function. Let's try the next one. H of negative x. Let's see what happens when we put a negative x in there. So negative x squared plus 1. When we clean it up, a negative times a negative is always positive, so it's just positive x squared plus 1. And then we go back and compare. Is it just like the original? Yep. And since it's just like the original, this is an even function. One more. F of x, x to the third equal minus 1. Let's see if it's even or odd or neither. So we're going to plug in a negative x in there and see what happens. So we said negative times negative is times another negative keeps it negative, right? 3 negatives make it negative. So it's negative x cubed minus 1. Now we go back and decide, is it like the original? Does it look like the original? It's not the original. Now, is it the negative of this? That would mean, is it negative x cubed plus 1? That's the negative version of that. All I did was change the signs. It's not that either, okay? It's not the negative of f of x. So that just means that this is a neither function. All right, and that's okay. You're going to have some that are neither. Okay, so hopefully that gives you some examples, and we'll do the in-class portion in class. All right, good luck. Thanks for hanging in there.